Welcome everyone to our plane mensuration series, the SSE aspect. Today we'll be dealing with the shape trapezium. The common diagram of a trapezium is given below. Here, area of a trapezium is equals to half into bracket open A plus B bracket close times H, which is the same as half the sum of the two parallel sides times height. From the diagram, you can observe that the two sides are A and B. They are parallel with the symbol of parallel indicated here. Then the height, it usually have the right angle triangle to it. And that's what we use in identifying the height. Next, let's treat some examples. 2013/30 NECO. Calculate the area of a trapezium ABCD with AB equals to 20 cm, DC equals to 45 cm, and height equals to 8 cm. The options are given. Solution. Area of a trapezium is equals to half sum of two parallel sides times height. And that will be equals to, substituting for the given values, we have half into 20 plus 45 times 8, which is the height. And that is equals to half of 65 times 8, which will give us 260 centimeters squared. Another example, 2009/49 NAPTEP, November. The trapezium below has an area of 456 cm squared. Calculate the distance between its parallel sides. The options are given. Solution. Area of a trapezium is equals to half of sum of the parallel sides times height. In this case, it will be equals to half into bracket open 17 plus 31 times h. Note that the distance between its parallel side is the h we are looking for here. Substituting for our given area, that will be equals to 456 will be equals to half of 48 times h. Simplifying, we have 456 will be equals to 24h. From here, h will be equals to 456 divided by 24, and that is h is equals to 19 cm. Another example, 2005/38 NECO. We have a given diagram. In the trapezium above, if line AB is equals to 38 meter, and line DC is equals to 58 meter, and line BC is equals to 25 meter, and angle BAD is equals to angle ADC, which is equals to 90 degrees, find the length AD. The options are given. Now, next, we look at our resulting diagram, which is given below. This is a deductive diagram. Note that in a trapezium ABCD, ABED is a rectangle, and the two sides of a rectangle are always equal. The length is equal and the width, they are equal. Hence, the deduction there, we have 38, which is given, AB is given as 38. So we can deduce that our DE is also 38. Next, the full length of DC, which was 58, will now be reduced to DE being 38 and EC being 20 meter. Please take note of the deduction we made here. It's very important. And also, we write it clearly that AD is equals to BE, because they are both sides of the rectangle within the trapezium. Applying Pythagoras rule to the resulting right angle triangle, 25 square will be equals to 20 square plus BE square. From here, the result is 625 will be equals to 400 plus BE square. And simplifying, we have 625 minus 400 will be equals to BE square. And that is the same thing as 225 will be equals to BE squared. And to get BE, we'll take the square root of 225. Thus, BE will be equals to 15 meters. Another example, 2006/30 NECO. A trapezium diagram is given below. The figure above is a trapezium. Calculate its area. The options are given. Solution. We can label our diagram as shown below. Area of a trapezium is equals to half sum of the parallel side times height. In this case, the problem we have at hand, from the problem diagram, we were only given one side of the trapezium, and then we're not given the height, we're not given the other side. Hence, the relabeling of the diagram. so that we can get the height and get the other parallel length. It is common knowledge that AB is equals to CD, which is equals to 10 cm. Reason, length of rectangle ABCD. Applying Pythagoras rule to the resulting right angle triangle ACE, sine 60 degree is equals to AC over 12. Using our SOHCAHTOA, opposite over hypotenuse. Simplifying, we have 12 sine 60 will be equals to AC. The result is AC is equals to 12 root 3 over 2 centimeter, which is the same as 6 root 3 cm. Also, cos 60 degree is equals to EC over 12. Applying SOHCAHTOA, car adjacent over hypotenuse. The result, when we simplify, is 12 cos 60 is equals to EC. And that will give us, from our trig ratio, cos 60 is half. So we have 12 times half will be equals to EC. That is to say EC is equals to 6 cm. Having gotten these values, it means we have our height and the two sides of the trapezium. Having gotten the first parallel side AB to be 10 cm, now we have our EC, which is 6 cm. So we just add it to the other 10, and that will give us 16. It means that ED is equals to 60 cm. So we can now move to area of trapezium is equals to half into bracket open AB plus ED times AC. That's sum of the two parallel sides times the height. Substituting, we have equals to half into 10 plus 16 times 6 root 3. The result is equals to half times 26 times 6 root 3, which is equals to 78 root 3 cm squared. Another example, 2005/3A NAPTEP November. ABCD is a trapezium in which AB is parallel to CD. Line AB is equals to 20 cm. Line DC is equals to 10 cm. Line AD is equals to 16 cm. And angle BAD is equals to 30 degree. Calculate the area of the trapezium. Solution. From the diagram given, we have the two parallel sides which is needed for the area of a trapezium, but we're not given the height. But we're given the slant height and an angle 30 degree. So we redraw the diagram as labeling it as given below. Area of a trapezium is equals to half 10 plus 20 times DE, which is half sum of the parallel side times height. We solve for DE in triangle ADE using trig ratio. Sine 30 degree is equals to DE over 16, which is so from SOHCAHTOA, opposite over hypotenuse. Simplifying, we have 16 sine 30 equals to DE. And we know that sine 30 is the same thing as half from trig ratio, which is 16 times half is equals to DE. And that will give us 8 cm equals to DE. Substituting for the area of the trapezium, we have equals to half into 10 plus 20 bracket open and close times 8. And that will give us 30 times 4. The result is 120 cm squared. We've come to the end of the examples under this subheading areas of trapezium. Next, we have some exercises in our book, New Hidden Facts in USSC Mathematics, page 345. Please try your hands on the exercises. The answers are given at the back of the book. The hard copy are available in bookshop. If you're interested in the soft copy, try our website, which is written at the bottom of the screen. Thank you.